All right, good morning, everyone. You haven't met me yet. I'll start off by introducing myself. Good morning, Calgary. My name's Don Burks. I'm head instructor for web here at Lighthouse in Vancouver. I've been with Lighthouse now for almost 5 years. I started in the third cohort, so I think you guys are my 63rd or 64th cohort that I have done. I promise I'm not bored yet. A little bit of background on me. I've been a professional web dev for about almost 21 years now. I've run a couple web design companies. I've worked for Microsoft. I was a senior dev for MetroLyrics.com for 2 years. Done about a dozen startups. Currently involved with one right now. I started off with a degree in music. I'm entirely self-taught in terms of programming. I've actually never taken a proper programming class at any point. I wish there had been boot camps when I started, but to tell you precisely how old I am when I started doing professional dev, there was no Google. So that was terrifying. We knocked rocks together to make fire at that point. Quirky fact about me that I will share. I'm really fascinated by the idea of biohacking. So I actually have an RFID chip implanted in my hand. So you can come up with your phone and you can boop my hand if you have NFC turned on or RFID, and you'll get my contact info just out of my thumb. So that's a brief introduction to me. Today, once everyone gets here, good morning, we're going to get started and we're going to talk about two main concepts, functions and callbacks. Now, functions, you've already been working with functions, you've been writing functions, you probably feel pretty comfortable with functions, and I want to make you even more comfortable with functions. Because JavaScript, bless you, I was allergic to them when I first started too, so don't worry. JavaScript's use of functions is unique amongst languages. The way that it treats functions, methods, whichever word you want to use for them, is pretty unique. Calgary, just so you know, I have Slack open on my phone here on the podium, so if you say anything, I promise I'll catch it right away. Let's dive in. In JavaScript, we have two primary ways to declare a function. We can write a function, and this syntax, invoking the function keyword, is basically creating this function in memory called doStuff. And then if I want to run doStuff, it does what I expect it to do. Except there's a trick about line 7 that most people don't realize. And the trick about line 7 that most people don't realize is that line 7 has two parts to it. There is this part, and there's that part. And those are two very separate things. If I take this off, that is still a valid line of JavaScript. Because what that does is it goes into memory, and it looks at what's stored in the name doStuff, and it returns it. If I was to do that, you would probably be really comfortable with that JavaScript because I'm creating a new variable called x. I'm setting its initial value to 5. I am then fetching the value of x. I'm not doing anything useful with it, but I'm fetching that value of x. My function doesn't work any differently. Line 3, I declare a function called doStuff. And then on line 7, I go into memory, look at what's stored in the name doStuff, and return it. But I'm not running that function on line 7. I'm just getting a reference to that function. I don't actually run that function until I choose the syntax of sticking parentheses on the end of it. Pretty much guaranteed across most of the programming languages you will ever encounter, as soon as you have a word immediately followed by parentheses, you are invoking a function. JavaScript is especially no different. And in fact, that is a rule in JavaScript that is incredibly important to us because it's what allows us to treat functions like variables. So I said we had two ways to create a function. And we do. So the first one is on line 3. And the second one is on line 13. That is 100% valid JavaScript. I am creating a variable called doOtherStuff, and I am assigning its value to be a function. And that means I can now do other stuff. And that's going to work. And the reason that's going to work is for the same reason that line 7 works. It's a two-part process. The first part is JavaScript is going to go into memory, and it's going to look and see what is stored in the variable doOtherStuff. What is stored in that name. And it's going to find a function. It's going to return that function to me, and then it's going to let me run that function with me putting the parentheses on the end there. Me sticking the parentheses on the end is me invoking that function. Comfortable so far? Cool. So, if that means we're allowed to do this, that means functions are objects. And we have names for these two methods of working with functions. This one is called a function declaration. I am declaring the function. You know, me firmly putting my foot down as a dev and saying there is going to be a function called doStuff. So that's a function declaration. This one is called a function expression. Now they're both functions and I can run them the same way, so why do we need different names for each one? Well, there's a simple answer for that. The reason we need different names is because we are actually handling the mechanics of creating those functions differently. What we actually have on line 15 is an expression of code. It's not just a definition, not just a declaration. Because I could be storing a function there, I could be creating an array there, I could be just an integer, a string, anything like that. You know, like what I did on line 10. But what I did on line 15 is I used the syntax for creating a new function and said I want to store that in the name doOtherStuff. So that's an expression. So what's interesting now, oh, and by the way, that's why I had to put the semicolon on line 17, because that is JavaScript's period at the end of a sentence that says, hey, I'm done with this expression. This operation is now done. That's also why I didn't need one on line 6. That's not an expression. That's a declaration. So if I can do this, this now explains why I can create a list, extremely complicated list, and do that. You've probably seen a for each before. If you have, well, you might have come across it in the prep course. For eaches are cool. And here's why. It's a function, a method you have available on an array. And it is exactly the same . It's exactly the same as me doing that. The code from 23 to 25 and the code from 27 to 31 are identical. Connor from Calgary gets extra points for bringing up the story that made the rounds yesterday about a guy who basically a researcher discovered that malware could be encoded into a strand of DNA because they're starting to use DNA for storing data as a data storage mechanism, because you can get a ridiculous amount of data stored in a single strand of DNA. If you think it's crazy that we can have a 1 terabyte micro SD card now, imagine being able to have like a 1 petabyte SD card, where you're walking around with like Wikipedia on an SD card. We're almost there, but apparently somebody's figured out, well, if I can encode any data I want in DNA, then I can also stick, literally, a virus into DNA. So, anyway, tangent. Back to this code. Yeah, 23 to 25 and 27 to 31 function identically. They're going to produce the same output, and at a step-by-step level, at a logical level, they are doing exactly the same thing. But it's two different approaches to the same problem. So if we look at 27 to 31, we're doing our standard for loop. We are creating a new iterator variable called I. We are going to have a conditional at the beginning of each loop that's going to check and see if I is less than the list.length, the dot being the property lookup operator there. And after each run of the loop, we're going to use the increment operator to boost I's value by 1. When we get into the loop, we're going to create a variable called X that is going to hold the current element of the list that we want to look at. And then we're going to console.log X. That's a standard for loop. Everybody comfortable with that? Yeah.
How would you done the second option? Going backwards in the list? How would you do that?
Oh, we'll get there. That's an excellent question. Calgary, the question was, how would you go backwards through the list? It's almost like you read my mind. We're going to do that in just a minute. So yeah, that's your standard for loop, and that is what we call the imperative style of coding. And the reason it's called the imperative style of coding is we are telling the computer how to do what we want it to do. Programming, at the end of the day, is us knowing the solution to a problem and breaking it down into steps so simple the computer can do it. The computer's a dumb box on the best of days. If you remember the comedian Mitch Hedberg, R.I.P., he had the great quote that my computer can beat me at chess, but I can beat it at kickboxing. Your computer's a moron at the absolute best of times. But what we're able to do is, as humans, we can come up with a solution to a problem, and then we can tell the computer in a language it understands, JavaScript, how to do that solution. That's what coding is. It's not math, it's language. So if we're telling the computer how to do this, we're being imperative. We're dictating to the computer the steps that it's going to follow. And in that situation, a for loop is going to work every single time. Your for loop is your go-to function for looping over anything. If you don't know which function is the right function to write, but you know you need to do a loop, write a for loop every single time. Working code is worth more than pretty code every single time. Working code ships, working code generates revenue, working code can always be refactored later. Pretty code that doesn't work gets you fired. Plain and simple. Like, oh, well, I picked the perfect method. Yes, but your code is broken, therefore it's no good. But it's pretty. Don't care. Pretty only works in beauty pageants. So, 23 to 25, on the other hand, it's written more concisely. But it's doing the exact same thing. We have a name for this as well. This is called the declarative style of coding. And what this is telling the computer to do is I'm just saying, here's what I want you to do. For each element of the list, run a function, bless you, run a function on that element. Take that element, pass it into the function as a parameter. So, that's why I named the two things the same. The parameter going in on line 24 for that function is x. And on line 30, I created an x. And so the work that we're actually doing in both cases is we're just console.logging x. But in line 24, I'm saying for each element of the loop, run this function on it. If I was to hand you a deck of cards, and I was to say for each card in the deck, deal it to the next player, you'd probably be pretty comfortable with that logic, that language. If you were making sandwiches for a soccer team, for each slice of bread, smear some mayonnaise on it. You'd be comfortable with that. That's an action that you are doing for each element that you have to work with. Well, that's what line 24 tells us. So this is a built-in function in JavaScript, a declarative function that we can run on arrays. And there's a number of them that we have. We have for each, which does this, and it's just another way of doing our for loop. But by itself, list.forEach is just a function. So there's a word that gets looked up by JavaScript. It's a property on the array object, gets looked up by JavaScript, and then we try and run it as a function. Now, by itself, for each, if I just run this, I will get no output because I have not given it anything to do for each element of the array. But if I give it something to do, if I give it an operation that it can do each time, depending on what I tell it to do, it will do it. So in that case, on line 25, I told it to console.log x. I could also say console.log x plus 1. Different function. This time I'm going to have it log out x plus 1, different action. Same for each. I'm still looping over the array and doing something to each element. But in this case, I'm choosing to take a different action. I could take each one of those numbers and put it in a database. I could take each one of those numbers and send it as a text message to my mom. I could take each one of those numbers and I could multiply it by 10,000. Whatever I want to do inside that function is mine to declare. So with that being mine to declare, that means I'm in control of that action in response to that change in data. Yeah?
Sorry, I just can't tell from back here. Your declarative functions, are those curly brackets or are they square brackets?
They are curly brackets. So the question was, for example, line 24 and 35, are those curly braces? That's my editor. Does that help? No problem. So the function is just console.log x. Not quite, Thomas. The function is everything from here to here. That's the function that I am running on each element of the array. What I am doing inside that function could be just console.log. It could be 16 or 17 different operations that I want to run. Because it's a function, I can put as much inside the body of it as I want. Correct. If you just did list.forEach and then x, it's not going to do anything. And in fact, you're going to get an error in that case because the expectation of for each is that the first parameter that is passed is a function, something that JavaScript can actually run and pass the data to. Make sense? Cool. So we've written some code out here, and I've written a bunch of code in this file. Let's actually hop into the REPL, and let's see this code actually do something. So we've recreated our list. Quick question. Where did the undefined come from? This is my favorite pop quiz of week 1.
Because you haven't run any.
It is not because I haven't run anything yet. Where did the undefined come from? I like where you're going, but you're not quite there. So the answer there was you're not returning a value. Darren says it didn't output anything. That's not correct. Well, you're correct. I didn't output anything. That's not why I got back undefined. You were close, though. I usually keep a stack of virtual cookies on my podium, and I give them away for right answers. You almost got a cookie. Is it because list doesn't have a defined value because it's an array? No. The var was undefined before you added the value. Also no. I'll give you a hint. The answer starts with the letter R. I'll give you another hint. The answer starts with the letter R and is a word on every one of your keyboards. Pauline wins. Return. Well, here's the thing. We didn't return anything. That's correct. We didn't return anything explicitly. The undefined is the return value from doing this operation. Declaring a variable by default has a return value of undefined. Every single action I will ever do in JavaScript, from looking up a variable to looping over an array to writing a function to running a program, every single action is going to have a return value. Have you ever gotten the spinning beach ball of doom or the hourglass on Windows, blue screen of death, things like that? Yeah, that's when a function didn't, an operation didn't return. That is what causes a computer to hang. When an operation returns, that is the signal to the CPU to do the next operation. If we don't get a return value, we can't do the next thing. So, that's important to know. Yes, she gets a cookie. Okay, so we've got our list. Let's start off. Is less than list.length. I++. I promise I know how to type. Let's say var x equals list I. Console.log x. We get the output we would expect. 1, 2, 3, 4, 5. Quick question. What data type were all of those? Wrong, wrong, wrong. Not numbers, not integers. Yes, technically they're objects, but I'm not going to shave that hair that way. Everything in JavaScript is an object. That's the Descartesian I think, therefore I am of JavaScript. The 1, 2, 3, 4, 5 in yellow right there. Strings. Why are they strings? I made an array of numbers. What the heck? They are not defaulted to an array in strings. Or defaulted to strings in an array. Yes, you get a cookie. They are typecasted. Console.log says I want to output text to the screen. Therefore, it's going to take my number and it's going to turn it into a string. If I do console.log list, I get that. Because that's what an array looks like when it gets output on the console. So, fun facts for your day. So let's look at the other one. Same output. Functioned exactly the same, no perceptible difference in speed. Did exactly what we wanted it to do, was just easier to type. So what happened there is the for each method on the array started at the first element of the array, which was list square bracket 0, the number 1. It took 1 and passed it into the function, so x now equaled 1. Same as we would pass any argument into a function at any point. And inside that function, we said we want to console.log x, we console.log 1. That loop was now, that iteration of the loop was now done. We went back, grabbed the next element out of the array, passed it to the function. X was now 2, console.log 2. I'm assuming lather, rinse, repeat is how I can explain what happened to 3, 4, and 5. So this is imperative versus declarative style of programming. One of the things with declarative programming, and you're going to see this a lot in JavaScript, and even that's an understatement. With JavaScript, when we have, what is the X reference? X is the, so Pauline, it's not X is the list. X is the element in the list for each iteration. The same way that up here in my for loop, I said var x equals list I. That's me showing what the for each does. Does that answer your question, Christoph? Well, I is kind of like X. Not quite. I is the index. X is the actual value from the array. Yeah. Okay. So the function in this case that I have passed to for each has a name for what I'm doing. And that name is what we call a callback. So callbacks are a pattern that get used in programming. Callbacks is not a library that we install. It's not a specific name of a function that we run that is built into JavaScript. Callbacks are a pattern. The same way I'm talking about this for loop versus the for each loop, these are patterns, the imperative versus declarative style. And the success that you're going to find in adopting all the fundamentals that we're trying to shove into your brain this week is not in memorizing all the functions. It's learning the patterns. Because the patterns are going to recur over and over and over and over again. For example, it's an unusual pattern for Leon to come in after 9 o'clock. This is a very unusual pattern. He's one of the few people that beats me here in the mornings. The flesh is weak, I get it. Yeah, struggle is real. This pattern of using a function as a response to a change in data, and that is your definition for a callback, is something you will see everywhere throughout JavaScript coding. Anytime we have a change in data and we want to have an action that takes place when our data changes, we call that a callback. If I, for example, run down the street down to like Hastings, and I find Crazy Eddie standing on the street corner shouting at his invisible dog, and that's actually a guy and he does actually do that, and I walk up and I punch him square across the jaw, he's going to probably take a swing back at me. Or go back to yelling at his dog, I'm not sure which. But him taking a swing back at me is a callback. There's been a change in something, and so that's his action in response. If I walk up and hand him $20, he's probably going to try and hug me. Different data, different action. So I now have a pattern that I can use in my code that mimics how I interact with things in real life. Let's go back to that deck of cards. So I'm playing slap, and I'm flipping cards over, and I'm waiting for the jack to come up, because as soon as that jack comes up, I have to hit, I have to slap the card. So my function is now flip card over, if card equals jack, slap, else do nothing. Well, there's no else at that point. That's my function. That's my callback. In that case, going with these variable names, my list is my deck. So I can sit here and flip these cards over, and each time the data changes, I have a function that I run that evaluates that change in data and does something in response. And then I can add whatever other logic inside that function that I need to track that change in data. So, I had mentioned earlier that we were going to do backwards. So let's do that. We have an array. Could be anything. Could be an array of arrays, it could be an array of integers, an array of objects, whatever. It's an array. So what I want to be able to do, and I'm always going to start when I'm attacking a new project like this, I'm going to start by pseudo-coding out what my human logic is. Because if I don't know the answer, JavaScript doesn't help. It's like trying to give someone directions in a language you don't natively speak to a place that you don't know how to get to. There's no do what I mean button. Apple hasn't given us that button yet. It's in next year's update, I'm sure. And if it was Windows, it would be next to the any key. So what I want to do is I want to loop through my list. I want to start at the last element and end at the first element. So that's my general problem that I want to solve. I want to loop through my list, starting at the last element, ending at the first element. So I need to start my loop at the last index. To get the last index, what do? How do I get the final one? Right. So to get the last index, I will take the length of the list and subtract 1, because the two hardest things in programming are naming, caching, and off by 1 errors. Then I'm going to check to see if the index is greater than or equal to 0. If that's true, I want to keep looping. And instead of incrementing, decrement the index each time. Inside the loop, output the correct element of the list. If you haven't been doing this for the past 3 days, you should. I know that none of you decided to become developers because you wanted to type. But without this, how do you know what code you're writing? Oh, but I'm clever. Just ask me. I'll tell you. Yeah, you're all clever. You're all smart. That's why we let you into the program. The point is, this is my recipe. This is my blueprint. This is me figuring out that solution to the problem. And now I have a step-by-step that I can go through and translate it into JavaScript. So, for var I equals list.length minus 1. I is greater than or equal to 0. I minus minus. That sounds like what I just wrote in English. So console.log list I. That should give me that solution, right? Okay. Let's see if it works. Yep, works. Fantastic. We've solved this problem. But we've solved this problem in an imperative style. Now let's go back and solve it in a declarative style. Actually, before I go on, was there anybody whose brain melted at that code? Speak now, please. A little bit? Okay. You want me to talk through it one more time?
Yeah, simple question. I get the code, but how, in which part are we telling the system to start from the end of the list?
So where are we telling the system to start from the end of the list is, is right here. We're starting off the value of I. Normally we'd start off the value of I at 0 for the first element of the list. This is setting the value of I, that's the starting value, as the length of the list minus 1. So this list, for example, has 5 elements in it. That means I is going to start off at 4. Yeah. And then it's going to check and see, is 4 greater than or equal to 0? Yes, even in the new BC curriculum, it's still a positive integer. And then afterwards, we will decrement it by 1. So it goes 4, 3, 2, 1, 0.
Oh, I was just getting mixed up when you write it, you start at size with 0 and then I.
Right. So it's good that you were following the pattern, and it's good that that confused you. But this is now, we're taking that pattern and we're expanding it out just one level, so that we're now seeing the bigger pattern of set a starting value, set a conditional, set some stepping operator change in that, and then it will end up being, the loop that we want. Make sense? Cool. Calgary, can I get a quick thumbs up from you guys that you guys are good? I got a thumbs up. Awesome. So this was our imperative version of this. So now what I want to be able to do is I want to be able to write my function backwards, and I want it to take in a list, and I want it to take in a callback function, something that's going to run on each element of that list. Bless you. I'm just going to abbreviate it CB for callback. This is an abbreviation you will see very, very frequently. It does not mean Citizens Band Radio, Smoking the Bandit. Not how this works. So my function backwards, I'm actually going to be a terrible human being. Bless you again. And I'm going to steal my for loop because I just don't feel like typoing that again. My loop is still going to work the same way. But this time, I'm going to call the callback function on each element of the list. So whatever is in the local variable CB, I'm going to run that as a function and pass the current element of my list as an argument to that function. And that means I can now call backwards like this. Go ahead and read that for a minute. Word is the name of the parameter being passed in. That's the argument being passed into the function. So that's going to be each element of the list. My function doesn't actually have a name. I wasn't sure if that was a question or a head scratch. Head scratch. A little bit of both. Okay, what's the question? WTF? Okay. Valid question. WTF, of course, standing for what's that for? Yes. Yeah. This is a for each backwards. Yeah. This is a for each that we have just decided to walk backwards instead of forwards. The logic of it is the same. So let's step through each and every piece of this. I've defined a function called backwards. This with a function declaration. It is taking two parameters. One of them is named list. So whatever gets passed in only has scope inside here to be named list. Doesn't matter that it's named the same as this, because this variable here on line 19 only has scope inside this function. I could have named it Rutabaga, Fluffy Bunny, whatever I want to name it. Because it's a list of things, I named it list again. If it helps, we will fix this name. What's another word for list? And don't say array, because array is a terrible name for a variable. Set. It's a set of data. Okay. So whatever the first parameter that's passed in to my function, it's going to get stored in the local variable set. Whatever the second parameter that's passed in, and I intend it to be a callback function, but whatever the second parameter is that's passed in, it's going to be stored in the local variable CB. So then I'm taking my exact same line, setting up my for loop that I had on line 14. And so I'm setting up my for loop to start at the end of the set and walk backwards over it. And for each pass over that set, what I'm going to do is I'm going to take whatever's stored in the callback and try and run it as a function. So the on line 19 CB there, that's a reference to the function. On line 21, that is me invoking the function. One has parentheses, one doesn't. So I'm going to run the function, invoke the function on line 21, and I'm going to pass it whatever the current index from my set is. Like I'm passing it that element of the set that was passed in as my first parameter. Well, the thing is I'm taking list and passing it in. Yes. My list still exists up on line 1. So that's my backwards function. And so now on line 25, I'm calling the backwards function. I'm passing my list in that I defined. And then my second parameter is a function. Because a function is a thing that I can pass around. If it's a thing that I can store in a variable, it's a thing I can pass as a parameter to a function. So I have a function, and I'm defining that function to expect one parameter being passed in. And it's going to go into the variable word. And then what that function is going to do is it's going to console.log word. Now, this function that's on line 25 is not being run at this point. It's just being defined. So everything from here to here gets set in the variable CB in my backwards function. Clear as mud? Shall we watch it run? Exactly the same. The other one's commented out, so we know that our backwards function ran. So just as a demonstration of this idea of it being declarative, same list, same backwards function, different callback. Different output. So now I can take any function I want and pass it as my second parameter and get whatever behavior I want for each one of these words to happen. Each time the data changes, I can register the action that I want to take place. Let's get really fancy. Oh, so until we call the backwards function, we won't know what the function CB does right. Yes, 100% correct. Because the function that's in CB hasn't been run until we get inside that for loop. In fact, not only do we have to wait until backwards gets called, we actually have to wait until the for loop starts running for us to know what that callback is doing. loser case. That's a new function I'm going to write. I can add whatever logic I want to this function. So I'm saying if the first character of the word is a capital T, then I want the word to be presented in all uppercase. Otherwise, I want the word to be presented in all lowercase. And the reason 2 wasn't put in all uppercase is because in the original array, it's in a lowercase. Make sense? Cool. So last thing we're going to talk about before we take a break. So I'm going to bring this file back up, the functions that we looked at initially. And I want to talk about this function here on line 15. So this function on line 15 is what we call an anonymous function. When I defined it after the equal sign, I didn't give it a name. Same as this function down here that I passed to for each. It didn't have a name. These are called anonymous functions because I haven't named them. Totally valid in JavaScript. My functions don't have to have a name. I could go back and name them. And my favorite name. I can name them if I want to. But I'm still going to call it the exact same way. It still do other stuff. So I'm actually going to copy this. Oh, actually, no, I'm not, because my lines are on. I'm actually going to copy this code right here. And we're going to hop out to Node. So we're going to define this. Quick show of hands. And there's very good reasons to choose either A or B. So show of hands, who thinks this will work? I have a named function. Given how I've talked about the way functions get parsed so far, theoretically it should be going into memory, looking up the name Fluffy Bunny, returning whatever's defined there, parentheses on the end, invoke that function. Who thinks we will get more things? Okay, I've got one vote here. I'm going to assume Calgary is discussing it eagerly and adamantly at the moment. Who thinks this is not going to work? Who has no frickin' clue? Cool. Fluffy Bunny is not defined. So if I name my function but I can't call that name, why in the bloody hell would I do this? Why would I waste 11 keystrokes on naming a function when I can't actually call it by its name? So I'll give you a very good answer for that. We've all seen the output when our code doesn't work and we get that stack trace of like, you got this error at this line, this error at this line, this error at this line when we tried to call this and this and this. That's the stack trace in JavaScript. Well, what happens is if we get an error in an anonymous function, it just tells us there was an error in an anonymous function. We don't know which one it was. So it is actually considered to be a best practice, though I will tell you only about 20% of the people do it. It's considered to be a best practice to name all of your functions, because then when Node gives you that output, it will actually say, in function named Fluffy Bunny, this error happened. And then you know where to go to fix your problem. Otherwise, you just get told that it happened in an anonymous function. If your file has 5 or 6 anonymous functions in it, you're flipping the table and going for a walk. So, yeah.
Can you name these two on each side? Can you name them the same?
Can I name them the same on each side? Yes, I can. And JavaScript will happily let me do that, which is dumb. I can name them the same. So and JavaScript lets me do that. And then when I run this, it works. But when I run this, it's because JavaScript is looking up this variable, not this one. And all I will get told in my output is that there was an error in the doThings function. Fortunately, because of how I've named it, it's easy to Command F and find in my file. But yeah, JavaScript is totally happy to let me name these the same, which technically is JavaScript being stupid. You know, that's the equivalent of, you know, when you've been in a relationship and your partner says, fine, do whatever you want. That's really what's happening here. I don't care what you name it. I'm not going to judge you. So, yeah. It will let me name it the same, but it's not a best practice to do that.
How is that how like that still helps like error?
It does still help error handling, you're correct. And by giving it that name, it means I can go and find it pretty easily. But if I had just a whole bunch of that, right? And you know, I got let's say I called like all these functions in a row, and all I got was there was an error in an anonymous function. Then I'm actually having to like track down my order of execution and figure out when that got called, and you know, carry the two, and like it's a mess, more of a mess trying to debug it than debugging normally is.
So if you name the function X,
Then I could find it much more easily because it would actually tell me that it happened in X. And it's not the worst practice in the world. Technically, though, I shouldn't be able to do it. I shouldn't be able to create two things in memory with the same name and have them store technically two different things. Because what's being stored in the variable in this case is the function object, and then what's being stored from function doThings is just the body of the function. So it's slightly different, and if you want to know more, go read the documentation for Node.js, because that's a really deep, like computer science-y kind of conversation. You're actually probably going to be checking the Node source code, so how good is your C++? Okay. It's not that I want to discourage you, and I will be happy to have the conversation later on today as far as what's going on behind the scenes. Has anybody not seen Wizard of Oz? Okay, good. Oh, never mind. Spoiler alert. We'll talk later. Yeah, I don't want to get too off topic. So yeah, anonymous functions are a thing. They are fine to use. Don't be afraid of using them. Just know that if you're at a point where you're having to track down debugging and it's just like, oh, it happened in an anonymous function, then naming the function gives you more clarity on what that's doing. Let's take a break. When we come back, we're going to look at more instances of declarative programming and callbacks. Okay, we are back. So, uh, we've looked at doing imperative and declarative style. We've looked at the two main ways that we declare functions. So we had function declarations and function expressions. So now what we're going to do, the same as we did a backwards for each, we're going to implement the forwards for each. And in particular, the reason I like to go through this exercise is one of the best ways to make sure that you understand how a pattern works is that you can write it manually. Like you can write the imperative version of any declarative pattern, you know it. And I'll make the analogy here. If anybody has either experience in the medical field or family with experience in the medical field, especially in hospitals, they have this teach, try, what is it? Try, do, teach something. I forget what the words are because if you'd asked me 5 seconds ago, I could have told you. But they have this pattern that they use for certifying someone to do a procedure. And the way it works is you first get trained, do, teach, that's what it is. You first get trained to do a procedure, say like putting in a chest tube. You get trained to do that procedure by somebody who knows and is certified to do that procedure. So they show you how to do it. The second time, you're going to do it yourself under the supervision of someone who's certified to do it. But you're not allowed to be certified to do it until you can train someone else to do it under the supervision of someone who's certified. So at the point where you can train somebody else to do it, that proves you know it. That proves you know how to do that procedure. So in this particular case, what I like to do is when I'm learning a new pattern for something, I like to actually go in and manually write out the code that implements that pattern. Like, if I'm learning a library like Angular or Vue or Google Maps or something, I'm going to actually try and go and build the mechanics of it myself so I understand what's going on. And she hasn't seen Wizard of Oz, so I can't make the pay no attention to the man behind the curtain analogy. But for those of you that have seen it, hopefully you get what I'm driving at here. Yeah, that's the one with the Tin Man. Okay, so she has seen it. So, that was a close one. Yeah, when Toto runs up, grabs the corner of the curtain, pulls it back. I forgot to ask Calgary, so sorry, guys. And I use guys in the most generic sense. When Toto grabs the corner of the curtain and pulls it back, we see the guy with the levers and the gears and everything. The head booms, pay no attention to the man behind the curtain, but we realize that what looks like this great big giant glowing magic head is actually just somebody pulling some gears and making it work. Well, if we want to understand the magic behind something like for each or any of the other declarative functions, pulling back that curtain and actually seeing what that mechanic is a great way to understand how it works. So we've looked at for each and we've seen how it works. So we're going to take a list. We'll do fruit this time. And we're going to implement a for each function. Now, because it's not part of an array, like it's not a property on an array, we're going to have to pass our list in. And then we're going to pass in a callback. And once again, we're going to use a very imperative for loop, because that is the core mechanic of looping over something like this. And at this point, that code should look pretty standard based on what we did before the break. Yes? No? Maybe? Go jump on a lake? Okay. So now if I want to run this, and this time I'll print out the length of each word. Yes?
I thought when you're using the for each function, you would have to
There's a difference between for each with a capital E run as a property on an array and me defining a function called for each. In fact, just to make it easier, there we go. Better? Cool. So let's see if it works. Apple, cherry, banana, durian. Yeah, that's the right letters, or right numbers. So that's cool. That means we've now at a basic level re-implemented for each. But let's hop over to the browser for just a moment. And I'm going to look up the JavaScript documentation on MDN, never W3 Schools. I'm going to look up from the actual source, Mozilla Developer Network. And I'm going to look at what it says for each, and I'm actually going to come down and I'm going to look at the syntax. And this is important because I see that what happens with the callback is the callback can take 3 arguments. The current value, like the element of the array that we're looping over, but it can also take the index and the full array that it's being applied to. Huh, that's interesting. So if I wanted to replicate that, the question becomes, like here on line 5, if I wanted to replicate that, do I have access to the index? There are only 2 options. Okay, I got 1 yes. Does anybody want to say no? Okay. Does anybody want to say no and believe it, or were you just saying no because I asked you to say no? No, actually. That's still totally... well, it doesn't matter if I declare the parameters on line 9. It's what is being passed to that function, not what the function is expecting. JavaScript will allow me to pass any number of arguments to a function regardless of how many are named. So I could have 1 parameter defined, but I could pass 10 arguments to the function. I can have 10 arguments. Oh, I could pass 147 if I really wanted to, if I wanted to type them all out. It would be terrible to maintain. Be like 6 lines long just to call my function, but I could do it if I wanted to. In fact, I think JavaScript will let me pass, I think the number is 2048, so 2K. I think it will allow me to have 2048 arguments passed to a function. Please don't test this out. But yeah, if I wanted to pass the index to my callback, do I have access to the index on line 5? Yes, I do. And that is as easy as passing I. I is my index. Do I have access to the whole list on line 5? Yes. And so I can pass it. So now I've fully implemented everything that callback expects. Whether the callback does anything with it or not, that's up to me to decide. I'm the developer. I write the code. When you were learning to drive and your parents told you something like, always remember, you drive the car doesn't drive you. I write the code. The code's not writing me. I'm the one in charge. So if I decide to do something with those parameters, awesome. I can do that. But knowing that every single time for each is called, JavaScript is going to pass those 3 parameters means I can use them if I want to. Yes?
Is it a good practice to just always include them so that if you need to work on something later, you have the access to them?
So the question is it a good idea to always include them so that if you need them later, you can access them? And Danella, yes, I'm going to do exactly that. And the answer to your question is no. Because now you're confusing the things, like you're defining variables that you're basically not going to use. And if you need to come back and add it, it's pretty easy to add a parameter. But Danella has requested, can I show how to print the indices, for example? So we're going to change the names of these just to show them. So here I'm going to print the index element is val. And yes, I know 1 should be first and 2 should be second. Work with me. So that's, this number here is the index, and this number here is the value. And if we look at that code again, list I here goes into val, I goes into index, and the list goes into set. I'm not doing anything with set, but I passed it. I don't actually need to use it if I'm not going to do anything with it. I don't need it. Everybody absorbed that? Cool, so that was fun. Let's do another one. So we have another declarative function in JavaScript called map. Make a bigger list this time just so we get more output. So the built-in function of map, let me write the code first. Num times 2. So here's what's going to happen with this. For each didn't return anything. For each just did whatever we said to do to each element. That is literally me saying, for each of these deco cards, deal it to the next person. What map does is map has a very specific return value. Map returns a new array. And it's going to be an array that's exactly the same length as the first one. And the values in the new array are going to be created by running the callback function on the original array. So if I have 10, 20, 30, 40, 50, 60, 70, 80, 90, then theoretically, based on this code, I should get back 20, 40, 60, 80, 100, 120, 140, 160, 180. Because the new array is the results of running the callback function on each element. Yeah.
Is it a new array or does it replace the
It is a brand new array. That is an excellent question. So the question was, is it a new array or does it replace the original array? It is a new array. The original array remains unchanged, which is super important. Surprisingly, one of the bigger jobs that you have as a dev is not remembering all the functions, it's remembering what they return. That's what you want to worry about memorizing. Map returns a brand new array. And so now, if I log out results and I run this, I get the array we expected. So that's a brand new array that was created by running that callback function on each element. Yeah.
The original array still there?
Yeah, the original array is still there, has the exact same values in it. It has not been modified in any way. It's like if I was to able to take a stack of $100 bills and magically change them into $200 bills. And if I could do that, oh man, I would have driven here in my Bugatti this morning. But yeah, in that the original stack of $100 bills would still be there. I just magically made a stack of $200 bills over here. So yeah, it's in fact, let's just print that out for funsies. Still there, hasn't been changed, hasn't been touched. I just looped over it, ran a function on each thing, and took the results and stored them in a new array. Yeah. How would I change the original array? how would I change the original array? Oh, if I made my own map. I would, so instead of pushing values into a new array, I would just actually set the index of the original array to it. Yeah. But we've run this one now. Let's make our own. So same as before. I'm going to pass in a list and a callback. So for each, we'd already talked through the mechanics of it before, so I didn't do the pseudocode then because we'd already done that. Now we need to do the pseudocode for my map. Loop over a list. For each element of the list, run a function on it. Take the return value of that function and put it in a new array. Oh, and return the array after the loop is done. Return the new array. Sound logical? They're like, yes, Don, you typed it. We're going to nod our heads. It's fine. I'm used to it. If only everybody else would realize that I was right, life would get so much easier. So there is actually a step missing here, though. There's one step that I need to do before line 9. And the step that I need to do is referenced in line 12. Create a new array. I have to do that first before I can push anything into it. I don't just get to, like, rabbits out of a hat, like, you know, magically create that. So we'll call it results. And I'll just create a new array. And then it's almost like this is a pattern that we've seen a few times. What was that you were saying about patterns, Don? So we know that we have to run the callback on the on that element, same as we did before, and map has the same pattern for what gets passed to the callback that for each does. That's why I went ahead and wrote that out. You could check the documentation if you wanted to verify. But how do I get this into the new array? I'll give you a hint. It starts with P. There we go. Cookie. So results.push. So I'm going to run the callback function, and whatever that function returns, I'm going to push into my new array. I could totally do this as 2 steps. I could say, you know, result singular equals CB list I list, and then push the result into the results. I could totally do that, and it's totally fine. And I don't care which way you write it. It's up to you. I tend to nest things inside of each other because that makes sense to me. And if it doesn't make sense to you, then you raise your hand and you're like, dude, what are you typing? But that's what happens. And now, our last step on line 13, return results. Let's see if it works. Nope. Results is not defined. Because I forgot to actually call my function. I know how to code, I promise. You were supposed to catch that. You were my spell check. And yes, Pauline is correct. The scope was wrong. Ta-da! This one up here and this one down here look dramatically similar. So that means it worked. So let's look at it again just to make sure that we understand what happened. Created a function declaration, takes two parameters, list and the callback. We created a new array. We looped over the original array that got passed in. Every one of those array elements got passed to the callback. We ran the callback on that element. We stored whatever that function returned in result. And then we took that result and we pushed it into the results array. And after we were done looping, we returned our results array. So on line 25, we create a new variable. It's called results too, but whatever. We ran my map, we passed it the list, and we passed it the callback function. In this case, that callback function is taking the number in as a parameter. It's multiplying that number times 2 and then returning that. We logged it out. We logged out the original list just to show that it hadn't changed. Yeah.
What would we do if we wanted to just take every, other part of every other index in our original list?
What would we do if we wanted to take every other index in our original list? We would do that. So then we would get 0, 2, 4, 6, 8 instead of 0, 1, 2, 3, 4. Yep, no worries. We are in control of what the stepping function is. Don't think that just because you always type I++ that you always have to type I++. Yes. Yes.
Just like you can change the list, you can also change the callback.
Absolutely. You mean, can I redefine the callback inside of my map? Sure. Kind of defeats the purpose of passing in a function, though.
But can you like change the function?
I could set callback to be a completely different function if I wanted to. These are not immutable variables. I haven't changed the way JavaScript functions just by applying a new pattern here. So yeah, inside my function, I could totally define CB to be something else, and it would ignore whatever that original function was that got passed in. It's no different than if I redefined list inside my map. It's just a variable that stores a value. That value in this case happens to be a function, but that doesn't change the variable's behavior. Does that make sense?
Yeah, so you can change the contents of CV, but you can't like modify it because you don't have access to.
Oh, so can I modify, like let's say this is a 10-line function and I want to tweak some aspect of it? Not really. I'd have to define a new function because the function becomes a whole object at that point. And so if I want to change that, I have to replace that function with a new definition. I can't really go in and edit the function at that point. Yeah. Sorry, I didn't realize exactly what you were asking, but yeah, okay.
Would you, like, can you name that function?
Uh,
Like, can you
Oh, yes. On line 25, I can definitely name this function. Let's call it callback 1.
Okay. And can you also like declare these functions out of scope?
Oh, yes, we can. And now you're the one that's ahead of me. Ask me that question again in about 7 minutes. Yes. Calgary, there's going to be a great question coming in about 7 minutes. You're going to love it. Okay, are we good with maps so far? Okay, let's do one more. And this one is going to be find. So, aardvark, bear, cat, dog, elephant. Why not? Mainly because I couldn't think of an animal. Fox. That would have been a good one for F. So, there's another declarative method called find. And this one is a good one to demonstrate because instead of just looping over and returning another array, find returns a single element of a list. So it's a slightly different pattern. But what find does is it takes a function and this function needs to return a true or a false. And the reason it needs to return a true or a false is because what find is going to do is return the first element of the list, of the array, for which this function returns true. It's like literally flipping over the cards until I get to the ace of spades. I'm trying to find something in my set. So I'll put parentheses around this just to be clear about what's happening. So animal.length equals 3 is going to return true or false. Those are the only two things that can evaluate to. Please note what I did not do, and I will write this out really quickly. Please stop doing this. Like from the bottom of my withered, shriveled little heart, I'm going to ask you to please stop doing this. If I have something that has already evaluated to true or false, please create a brand new Boolean value and return that one, because the first one wasn't quite shiny enough, but I've made a new one for you. It's beautiful, and I'm going to give you that one back. I've written 5 lines of code when one would do just fine. So this. That evaluates to true or false, and because in this case with JavaScript, putting parentheses around it causes that expression to be evaluated as a single thing, and yeah, it evaluates it to true or false, and then I return that. It's a lot easier to type, a lot easier to maintain, less curly braces, handlebars, mustaches, whatever you want to call them. So this should return the first animal whose length is 3. And for those of you who like to count, which one should I get back? Cat, yes. Let's make sure. Cat, meow. So it looped through and ran this function on each element of the list, but it stopped when it found the one that matched and returned that, and I logged it out. So that was cool. So you guys could probably quote this one to me by now. But trust me, I'm not going to treat it like grade 3 where you have to read it along with me. So now the question is, how do I do in an imperative way what I was doing declaratively before? How do I test whether something, if I want to make a decision on whether something is true or false, what do I use? Starts with an I. If. If, callback, list I, list. It's almost like this is a pattern. Now what do I do here? I'll give you a hint. It is one line of code. What am I going to return? Yes. Now, common mistake stops my loop entirely. Completely just eject button. So, can I add, oh sorry, I missed that one, Darren. Can you add a name for the 3 variables in the callback? It's confusing to look at when you don't you only have num. I apologize, I missed that entirely. So you mean when I'm actually calling it? So var animal equals my find list. You mean when I'm defining it here? Ah, okay. Sure, I can do that. I don't need to because I'm not using those values right now, but they're there for demonstrative purposes. Oh, wait. No. This is what happens when I talk and type at the same time. You'd think I'd be good at that by now. I did need that. Return beast.length triple equals, let's go for 8. Oh no, that's going to give me aardvark. We'll go for 4. Sure, why not? So this one should give me bear. By the way, this is the interactive portion of the lesson. Yeah. Okay. So, bear. So what did we do? We declared a function, 2 parameters. We looped through our list. If our callback returned a truthy value, doesn't have to be Boolean true, but Boolean true is the best truthy value. If it returned a truthy value, then we returned the element of the list that we were working on. Anything else, we just skipped over. So then we ran our myfind, we passed the list, we created our function. This one's anonymous, but we put all 3 parameters in there just to show that they're being passed. And our function is going to return whether or not the length of each beast is 4. If it is, it returns true. If it's not, returns false. So that whole function goes into callback and gets run on each element. And in this case, it got to the second one and stopped. So what happens if I change that? What should I get back? I've heard false, I've heard error. Undefined is the third option. When in doubt, try it and find out. You can't break it. Undefined. Undefined is what would be expected. Because literally there's nothing defined for that result. Null would have also been a good answer because nothing was found. But the actual implementation is not, or returns undefined. So you'd asked a really good question 7 minutes ago. Okay, 11 minutes ago. What was your question? So you actually asked it slightly differently before, which is, can I define this callback function somewhere else? This is why it was important that I started off by talking about how functions can be expressions or declarations, and how there's a difference between the reference to a function and running the function. So in this case, what I'm passing in line 21 is a reference to the function. So that reference goes into, like, it's the definition of the function, which is what goes into CB. It's still just a definition of a function, so when I run it on line 11, it still works. But now I can define this function somewhere else, and my code on line 21 is a hell of a lot cleaner and easier to read. The parameters being passed to it haven't changed. And in fact, none of my logic has changed one bit. But I've just cleaned up my code. Yeah.
What would happen if you call the function on line 21?
What would happen if I ran the function on line 21? Well, it's going to give me an error because beast isn't defined. So I can't test the length of the beast. So if I just put parentheses on the end of it on line 21, then basically what happens is JavaScript is going to run that function before it calls my find. At that point, it would be trying to pass whatever the return value of checkbeast was instead of the definition of checkbeast. So just to prove that it still works, it still returns nothing in this case. Let's fix this. Bear. So this is a common pattern you are going to see, where a function is defined in one place and then passed by reference somewhere else. So this is kind of cool. You'll see this a lot. Any questions about how I got to this point? Cool. So now I'm going to throw down a challenge to you, and I promise this challenge has a prize. So there's a valid reason, there's a substantive reason to do this challenge. We've gone over a couple of declarative functions today. We did find, we did for each, we did map. The challenge I want to put down to you is I want you to write me an implementation of filter, which is another one of the declarative functions. You have from now until 9 o'clock tomorrow morning to make a gist with your version of filter in it. There will be a prize for Vancouver and there will be a prize for Calgary for the best re-implementation of filter. So if you don't want to do it, you don't have to. If you want to earn a prize, give it your best shot. But this is above and beyond what you already have to work on today. So, fair warning. And the other thing I will say is please make sure that you read the documentation for filter and see what it does. But the part about this arg right here as the last function, you don't have to worry about this arg. Do not worry about re-implementing that at all. Worry about the callback. I want to see that you know how to do callback. So, yeah. You can send it to me on Slack. I'm just Don on Slack, so I'm easy to find. If you want to send it to me by email, don@lighthouselabs.ca, nice and easy. But yeah, send me a gist. It doesn't have to be a full repo because it's like one file. Send me a gist between now and 9 o'clock tomorrow morning. And then before lecture, I will interrupt Sam, who's doing the lecture tomorrow. I'll interrupt him right at the beginning and frustrate him by announcing the winner. Cool. Thanks, guys.